Hello everybody, and welcome to another video of the In a Nutshell video series. Today in this video we will have a quick guide on how to use the investment analysis functions of Excel. These functions start with the future value. Suppose that you receive a loan of 3,000 euros now in period 0 and you have a discount rate of 10%. What you want to know is the payback, the money that you need to give back as an equivalent value in future, and specifically 3 periods from now. Remember that you always need to have the discount rate at the same period as the analysis that you are making. So for instance, if your analysis is per month, so if this is 3 months, then this should be the discount rate, the monthly discount rate. If this is 3 years, then this discount rate should be the yearly discount rate. So the equivalent value for the future value in Excel, the syntax is like that, so equals to future value. So you need to give the rate, which is 10%, then the next value is going to be the number of periods, which is 3. In this case, there are no interim payments like you see here, so just put another semicolon, and then you have to give the present value, which is the loan that you got, that is 3,000 euros. And this is the syntax for the future value. This is the equivalent to the theoretical formula, which is future value equals present value times the coefficient f over p I n, where I stands for discount rate and n stands for the number of periods that you're going to transfer the value. So if I press enter, this is the value that I will get. So if I get a loan of 3,000 euros now and I have a 10% discount rate for the period, then after 3 periods I'm going to have to give back 3,993 euros. Keep in mind that Excel, when it uses the future value and the present value formulas, it changes the sign of the amounts. So for instance, if the present value is a positive amount, then the future value is going to be a negative amount, and vice versa. You need to play with the signs if this is not what you aim for. The second one would be the present value. So in this example, let's suppose that you need to receive 2,000 euros in 4 periods from now. Again, the discount rate is assumed to be 10%. So the question is, how much money do you need to deposit today so that you can get 2,000 euros in 4 years from now? You're going to find this with the present value formula. So that will be equal present value, and you have to give the rate. That is the rate. Then you give a number of periods, which in this case is 4. Remember, when you use Excel, try to avoid what I'm doing right now. So try to avoid to have numbers in the formulas. Try to use reference cells instead. And then there is no payment, and the future value is 2,000. So that's a positive amount. I'm expecting that the formula is going to reverse this amount and give me a negative present value. That means if I want to receive 2,000 euros in 4 years from now, with a 10% discount rate, if the period is the year, it might be month, it might be whatever you like, then the present value that I will have, the deposit that I need to do to make today is 1,366.03 euros. Another typical problem in this area of investment analysis is a loan that is going to be paid back in equal periodic installments. So now assume that you receive a loan of 3,000 euros, you have a discount rate of 10%, and you need to pay this loan back in 3 equal periodic installments. So the theoretical formula for this is A, which stands for the amount of each periodic installment, equals the present value times the coefficient A over P, I, and N. And this in the Excel is going to be calculated with the PMT value, which stands for payment, and PMT, equals PMT. So you have the rate, which is 10%, then you have the number of periods, which is 3, and then you have the present value, which is the loan that you received today. And obviously, I'm expecting that again, the sign is going to be reversed because the payment is going to be negative, something that I pay, while the loan was something that I received, so positive and negative again. And this amount would be equal to 1,206.34 euros. The exact opposite problem would be to try to find the deposit that I need to make today if I want to receive 3 equal periodic payments, or make 3 equal periodic withdrawals of 300 euros each. So in this case, I have to find the present value, and the present value would be equal to present value rate. Again, I'm using the present value function, but now the references are going to be a little bit different. So rate, that's going to be 10%. Number of periods, again, this is going to be 3. And now I have a payment of, I have a withdrawal of $300. So put 300 here, and that would give me, there's no future value, that would mean I have to deposit 746.06 euros in order to be able to receive, that will be the equivalent of receiving 300 euros for each of the next 3 consecutive periods. Obviously, the most useful function in Excel when I'm analyzing investments is the net present value. So assume that I have this kind of investment where initially in year 0 I need, or period 0, I need to invest 1,000 euros, and if I do that, I'm going to have a payment of 200 euros the first year, 400 euros the second year. I'm going to need to pay 500 euros in year 3, and I'm going to receive 4,000 euros in year 4. So I am preparing a table where I have for each period the values that correspond to each period. These are future values, and then I need to bring all these values in today's in the present value today. And in order to do that, I'm going to use the net present value equation, so I can do all together. I can do them all together. So that will be equal to net present value. I use the discount rate. This is discount rate in the same period as the periods that I have the values in my investment. So that will be 10%. And then I can select all the values. Pay attention to that. Net present value brings every value back in today at the equivalent value that they would have in present values. So that would mean that you need to start from one period from now. That is, you will not include in the NPV function what is happening today, what is happening in year 0, because this is already present value. So you're going to select what is happening from year 1 to year 4. In this case, you close the parentheses, but of course, do not forget to add the already present values, what I'm paying today, the initial investment, which is 1,000 euros in this case. I press enter, and then the value that I get is 1,869 euros. So this is the present value of my whole investment. And of course, mathematically speaking, if the net present value is positive, then your your investment is good, meaning that it yields more than your minimum acceptable rate of return, which is equal to the discount rate in this case. While if it is negative, it's not favorable because it means that it gives you less than the discount rate, gives you less than your minimum acceptable rate of return. If you want to calculate the internal rate of return, then this is very easy. You just do equals IRR, and you just pick all the values of all the periods. So that's it. In this case, you have a huge internal rate of return of 48%. As long as the internal rate of return is higher than your discount rate, then you are good to go. Thank you very much for watching this video. I hope it was helpful.